Hi folks, this is Karim Raouf from IT Visualizer channel. They will continue our lab matrix labs, the video number 134. I've been discussing in the previous video the following. We are still working with troubleshooting Windows using Microsoft Sysinternals suite, and we have seen the cases that was introduced in Mr. Mark Rosenbench PDF. He is the one that created the Microsoft Sysinternals suite. We have seen that he has about 4 or 5 chapters that are explaining the cases that was solved using Microsoft Sysinternals suite. So I have already took these cases and asked Claude 3.7 Sonnet to re-explain them in a simple way so we can all understand them. So we have now introduced, or we have discussed about 5 cases that was introduced in the PDF. Today we will continue the other cases. They are about 45 cases, so we are still have some cases to go. Let's continue with the cases introduced. Case 6, the installation failure. The next case is about an installation program that fails a strange error message that looks like it is performing an incorrect OS version check. Shows error with title containing O and message suggesting it does not recognize Windows Vista. So this is, as we can see here, this is cases that were introduced during the Windows Vista era. Okay, so even though this seems to be an old case, but we can use this case as a reference, okay, for future Windows operating system, because they are all, most of them uh, uh, are built upon the same, infrastructure. Okay, so Leo, let's run procmon or process monitor while attempting the installation and see what's happening. They run the installer with procmon capturing event. We see that this is the process monitor. We just tell him to capture, and then we can see everything happening on my PC. It is listed, all the programs that are working, all of the registry keys that are opened, everything is displayed in front of you. Okay, so let's go and see what will happen after that. After the error appears, I will use the crosshair to filter for just the installer process. Just a moment, guys. So let's continue, guys. Here Leo is taking the crosshair. This is something like this is the crosshair. You can take it and drag and drop, so you can just right click on it and then point on any program or any window, and then he will filter through this window the events related to this program. So for example, if I try to take the crosshair and put it on my cam recorder, it will filter all of the events in this window related to the cam recorder. So this is the crosshair feature. We have seen this before in the previous video. Leo filters the trace for the installation program. Let's execute successful operations to focus on potential problems. We have seen this before. Also, we have a lot of results. We have success, we have name not found, we have name not found. So he filter out the success to leave only the errors. Let's see how we can filter that. We can filter this. As we can see, we can tell him the result, so we can filter this one. Here we can see the result. It is, and then we can tell him to exclude his success. So if you do this now and tell him add this one, and then we need to tell him apply, and okay, now we have only all of the events that seems to be not success. We have name not found, we have file locked. Okay, so we can see that all of these are filtered from the successful events. If we need to return it back, tell him to reset the filter. Now again we have the success. So he have filtered out the uh, success operations, and after filtering them out, he have seen something called entries that's a pattern of does not exist appearing in past names. So you have seen here some of these processes that have a result of does not exist. So I think maybe can we have something like that here, maybe? uh, I do not think so. We have something path not found. We have a lot of things as you can see here, but I think we don't have something like that anyway. So We know how we can filter that. Basically, we can just remove the successful ones and then we can begin searching the errors. Okay, so now we have seen something called does not exist. Then he goes, I'll highlight all instances of does not exist to make them stand out. Let's see here. Leo setups highlighting for does not exist. I think there is a feature called highlighting. Let's see if we can. So we can highlight. What is the highlight? Okay, so I think yes. Let me, for example, first try to make a filter, and then again we can tell him architecture or tell him result. Let's see something like that. Is or exclude. We have success. Okay, and then add, and then apply and okay. So I think when he tell him filter to highlight, which things we need to highlight, for example, to make them, let me for example take result name not found. I think it will highlight it by making it by selecting them or by putting them in a different color. For example, result is name not found, and then we can tell him uh, include, add, and then tell him apply and okay. So now we see has already filtered them or have highlighted them, as we can see, with a different color, which seems to be a good thing. By the way, we can filter things and highlight them and discover them by color. So let's remove everything. We help him to reset filtering. So again we have everything up and running. So here he is filtering them or highlighting them. Now let's restore success result to see what led up to these operations. So he need to see why we have reached it does not exist. So we will see all of the steps beginning from success until he reached the does not exist. I can see now the installer reads setup.ini and autorun.inf files and then immediately tries to access a registry key called does not exist. So this is it. The autorun and setup.ini are files that the software uses to set up and install itself. So these files contain an entry to make the program write something to the registry, and this registry key does not exist. So this seems to be good. Let's look at the call stack for one of these registry operations to understand why. So we can go to the registry key and see the stack. What is the stack? This is something I was actually uh, did not know what is the stack. So I asked Grok and ChatGPT and Gemini to explain it. So explaining the stack tab in the process monitor in layman terms, imagine you are trying to figure out why a program on your computer is acting up like maybe it is opening a file it is not supposed to. The process monitor tool is like a detective that watches everything the program does in real time. It tracks stuff like opening files, changing setting, or anything else the program is up to. Now, the stack tab in the process monitor is like a trail of breadcrumbs that shows you exactly what the program did step by step before it performed a specific action. So this is what we need. We need to see when the program installs itself, the steps it follows until it reaches this error related to the registry key. Think of it like a replay of the program moves laid out so you can follow along. A simple analogy: picture this. The program is a chef, and the action you are curious about is the chef grabbing a knife. You want to know why the chef grabbed the knife at that moment. The stack tab shows you the sequence of steps that the chef took, like walking into the kitchen, opening a drawer, and then reaching for the knife. By looking at those steps, you can figure out what led up to this action. So we can see very, very simple things. What are the stack? How it works in the computer. In the computer world, those steps are bits of code that the programs run, called functions. Okay, the stack tab lists these functions in order, showing up the path the program followed right before it did something like opening that file. It's like a map of program thought process. First it did this, then that, and finally it opened the file. So why this is helpful? For sure it is helpful so we can know if an error happens, the steps that led to this error. This is super useful when you are trying to solve a mystery like why did the program do something weird. The stack tab shows you the lead up so you can spot where things might have gone off track. Is the program working correctly? You can check the steps to make sure it's doing what it's supposed to. So for example, if a program unexpectedly opens a file, the stack tab doesn't just tell you that it happened, it shows you why by revealing the sequence of actions that led to it. It's like watching a slow motion replay of what the program was thinking. In short, the stack is your detective notebook for a computer program. It gives you a clear step-by-step breakdown of what the program did before a specific action, make it easier to understand its behavior, fix problems, or confirm everything running smoothly. No tech wizardry needed, just a simple trail to follow. So very, very simple thing. So for example, here in the case, he's saying that he need to see this registry, the registry key. He need to see the stack of this registry key. Okay, what led to this action? So he can go to the registry, for example, any one of these, name not found, for example, then him right click and then properties. We can go to the stack. Now we can see all of the things that led to this thing or name not found, all of the files that are opened, all of the things that are implemented. So this is very, very, as we can see here, we can save them, for example, as a CSV file. So this is one thing. You can see a lot of things. You can see properties of this DLL file. Anything you need to do, you can copy them all. So we have a lot of options to do. So this is the stack uh, explained by Grok. As for uh, ChatGPT is saying in Process Monitor, you can select an IO or registry event and open the stack tab. Shows you the call stack for that event. That is the chain of internal steps the program went through just before doing the action. In really simple terms, think of calling a friend who then passes you to another friend who then passes you to someone else until you finally reach the right person. The stack is like the list of everyone you were passed through in order. In software, instead of people, you have functions or routines inside the program, and the system DLLs handing off the work to each other. So if a process monitor captures process X read this file, the stack tab will show you which function inside your program asked it to open the file, which operating system routines that call went through next, and so on all the way down to the lowest level drive. So this is the stack, and what does it mean? As for Gemini, it is saying it the stack. Think of it that your computer program does something, say reading a file. It doesn't just happen instantly. Inside the program, one piece of code, a function, often tells another piece of code what to do, which might tell another piece, and so on, like a chain of commands. So this is the stack. If we see at the end, again, a certain explanation, the stack tab is like asking the program, for this specific action you just took, what was the sequence of internal orders that led you to do it? It shows the internal call history for that specific moment, helping you track back the steps to understand why it happened, which is crucial for fixing programs or understanding complex software behavior. So this is the stack. So we have seen the registry key that contains that not exist, the stack of this registry key. Interesting, the installer is calling get private profile string. So the installer, there is a function called get private profile string, which normally reads from .ini file. So this function in the program or the installer program runs this function that reads from .ini file, a certain .ini file, but here the registry access is coming from the same function. So this should read from .ini file, but instead it is reading a registry key. So this is a normal behavior. There is a Windows feature called INI file mapping that can redirect .ini file access to the registry. So there is a feature that can do that. Just redirect reading the .ini file to reading the registry keys. So they locate something, so he will go to the folder that contains the installer of the program and the other files, and he have seen a file, something called .ini file mapping. He open it and he see that there is a line that this function relating to this function that reads or redirect it to read a registry key. So the file mapping registry key showing auto run redirected to does not exist. Mysteriously solved. Someone configured the system to redirect autorun.inf to a non-existent registry key as a security measure to prevent autorun-based malware. But this legitimate installer depends on reading its autorun.inf for configuration setting. Okay, so the security measure is breaking legitimate software. Exactly, the solution is to remove this redirection since modern Windows versions already have better protection against auto-run threats. So maybe this is in the Vista, an old version. Today, Windows 10 and other programs or other software or new Windows operating system can protect themselves from something like that. They demonstrate removing the registry setting and successful running the installer. So he have removed this line from INF file mapping, okay, and this solved the problem. That was a complex one. The error message gave us no clue about the real issue. That's the value of tools like Procmon. They show you exactly what's happening, not just what the software is telling you. So this is case number 6. It seems to be a little bit conflict or a little bit complex. So I asked Grok to explain it in simple terms. So here we can see that here is the explanation of this case. Imagine you are trying to install a program on your computer but it keeps failing with a weird error message. The message talk about Windows Vista, like the program thinks you are using an old version of Windows that it does not recognize. So is maybe you are installing it on Windows 10 but it thinks that you are installing it on Windows Vista, and there is a strange O in the error title. It's confusing and doesn't really tell you what's wrong. To solve this mystery, you and a friend decide to use a tool called Process Monitor or Procmon. For short, think of Procmon as a super smart spy that watches and writes down every single thing the installer does on your computer, like opening files or checking settings. It's like having a video camera recording everything behind the scenes. So this is the steps. Here is how we figure it out step by step. Spy on the installer. You start the installer and let Procmon watch what happens. When the error pop-ups, you got a detailed log of everything the installer tried to do. Zooming in, your friend uses a cool feature in Procmon called Crosshair to focus only on what the installer was doing, ignoring all other stuff your computer is up to, like running your browser or music player. Okay, looking for trouble, you will tell Procmon to hide all normal stuff that worked fine, the successful operation, so you can zero in anything that looks a problem. Spotting a clue. In the log, you have noticed something odd. The installer keeps trying to find something called does not exist in different places, but it can't. This sounds like a red flag. Highlight the suspect. To make it easier, you mark every spot where does not exist shows up so it stands out in the log. You have seen this? Rewind the tape. You bring back the normal actions to see what the installer was doing right before it hit these does not exist problem. It's like rewinding a movie to understand the plot. Following the steps, you see that the installer reads two files, setup.ini, autorun.inf, which are like instruction manuals for the program. Right after that, it tries to check a setting in the computer registry. A big storage spot for setting called does not exist, but it fails because there are nothing there. Digging deeper, your friend look at the call stack, a kind of map showing what the installer was doing step by step when it hit the error. It shows the installer using a tool called get private profile setting to read those instruction files, but somehow they got redirected to the registry instead. Okay, uncovering a trick. You find out that there is a Windows feature called INI file mapping that can reroute requests for files like autorun.inf to the registry instead. Someone set it up so that when the installer looks for autorun.inf, it gets sent to does not exist in the registry, a place that does not even exist. What is happening? The redirection was properly set up as a security trick to stop malware, bad programs like viruses from using autorun.inf to sneak onto the program. For example, some viruses use autorun to start automatically when you plug in a USB drive. This is a famous thing. By pointing it to does not exist, the virus cannot find what it needs to run. The problem, unfortunately, the installer isn't malware. It is a legitimate program that needs autorun to set itself up properly. The security trick is accidentally blocking it, causing the failure. So fixing it, you remove the redirection setting from the registry. Modern Windows already have better ways to stop malware, so this old trick isn't needed anymore. Once it's gone, the installer works perfectly. So redirect the setting from the registry. Lesson learned: the error message about Windows Vista was totally unhelpful. It didn't hint at the real issue, but Brockman let us see exactly what was going wrong, step by step, like a detective solving a case. So we can see, in simpler terms, the installer was failing because a security setting was hiding an important file it needed, sending it on a wild goose chase to the non-existent spot. By turning off that setting, you can fix the problem, and the confusing error message didn't help at all. Okay, glossary. We have seen I asked it to give us a glossary of technical terms. Process mon, this is the program. Crosshair, we have seen this feature. Filter, registry, call stack, get private, in file mapping, auto run. So all of these are glossary. As for for ChatGPT, I asked it the same thing to explain this case. What was wrong? A software installer pop-ups an error claiming it does not recognize your Windows version, Vista. The message is misleading. Windows itself isn't at fault. How we investigate Procmon, a black box recorder that logs everything and registry action uh, and every file and registry action a program makes. We run the installer on the process monitor and then filter to show only the installer activity, hide all the successful lines to spot any failures, noticed a bunch of does not exist errors. The surprising discovery: the installer first tried to read its usual configuration file, setup.ini Outron.inf. Instead of reading from disk, Windows redirecting those reads into the registry, its internal setting database. Because of the registry key pointer does not exist, every attempt failed, so the installer acted as if the file really wasn't there. Why did Windows do that? Windows has a feature called .inf file mapping that lets administrator reroute .ini file reads into registry keys. Someone had purposely mapped autorun.inf to a fake key does not exist to block autorun based malware. So the solution removed the bad in-file mapping entry for autorun.inf. After that, the installer can read its .ini file on the disk normally and complete successfully. I think the explanation of Grok is good. If I try to see for Gemini, Gemini seems to be giving more details. Okay, but as for a simple one, we can see that Grok is the winner. Okay, so again, this is a case. If we go to case 7, the unreadable text files. Here is a case with a curious setup. Multiple application couldn't read text configuration files, though standard text editor like Notepad could open them fine. That's odd. If the files are readable by some programs but not others, what could cause that? Let's use Procmon to compare traces between a working and a non-working application accessing the same file. They set up two Procmon traces, one showing Notepad successful opening a text file, another showing an application failing. Let's hide successful operation in both traces and look for differences. After filtering, they examine the remaining operation. The failing application has access denied results when trying to open HKLM software with the right permissions. So this is strange. Why it need to go to the registry and modify something in the registry or write something on the registry? This is only a read process. But why would it need write access to the registry just to read the text file? Leo, let's look at the call stack for one of these events. They examine the call stack from the access denied event. Look at that function, write private profile string A. This is a part of Windows Profile API which is used to read and write .ini file. Strange, again, why we do need that? But you are not dealing with .ini file, they are just regular text file. Then let's check if there is any an in-file mapping issues like our previous case. So maybe there is something that will redirect. Okay, instead of opening the file, it will redirect it to right to the registry, like the previous case. They examine the registry. There it is. Someone set the default value for the .ini file mapping key to sys instead of creating a specific entry for auto-run.inf. This causes all profile API calls to be redirected to the registry. Again, the default value for the INI mapping key to sys instead of creating a specific entry for auto-run.inf. This causes all profile API calls to be redirected to the registry, so any application using those API to read text files would try to access the registry instead of the actual file. Again, this seems to be odd. I cannot understand, but let's continue with the case and try to re-explain it. And many older applications use these APIs even for non-INI text files. Removing this incorrect registry setting will fix the issue. They demonstrate removing the setting and successfully opening the text file. This seems related to the previous case, both involved in-file mapping misconfiguration. Good observation in troubleshooting recognized patterns across cases can help you solve problems in the future. Let me try also to get this case and try to explain it in a more simpler thing. Let's take this one, copy, and ask Grok explain this case in layman terms, include terminology glossary. So let's see if he can explain this in a more simpler things. So let's see the explanation of Grok. Here we say that imagine you have got a simple text files on your computer. Think of them as the basic instruction manuals or notes. Normally, any program should be able to open and read them without a hitch. In this case, though, something weird is happening. Programs like Notepad, the basic text editor that comes with Windows, can open this file just fine, but other programs, especially some older ones, cannot read them at all. It's like some apps are being told, sorry, we are not allowed to look to add this, even though the files are sitting right there on the computer. What's going on? To solve this mystery, two troubleshooters, Leo and Maya, decided to play detective. They use a tool called Process Monitor, or Procman at short. It's like a super detailed diary that tracks every move of a program makes. Like try to open a file or check a setting in there. It's their way of peeking under the hood of the computer to see what's breaking. Now here is how they figure it out step by step. Setting up the investigation. They run Procman twice. First, they watch what happens when Notepad opens one of these files, text files successfully. Then they watch what happens when one of the failing programs try to open the same file and can't. This gives them two diaries to compare, one where everything works and one where it doesn't. Narrowing it down, they look at both diaries and hide all the stuff that went smoothly, like when Notepad worked fine. This leaves them only with the actions that might show what's going wrong in the failing program. Spotting the clue. In the diary for the failing program, they notice something odd. The program is getting access denied message, especially it's trying to write to a part of the computer called the registry, a big store area where Windows keeps setting and rules, and it is being told no way. But here is the head scratcher. Why does a program needs to mess with the registry just to read a simple text file? This like needing a key to a locked vault to read a note on your desk. A good analogy. Digging deeper to get more details, they check the stack, something called the call stack, a kind of play-by-play list of what the program was doing when it hit this roadblock. In that list, they see that the program was using a tool called write private profile string A. This tool is a part of something called the Windows Profile API, which is usually used to handle special configuration files called .ini files, not regular text files. A big aha moment. Wait a second. These aren't .ini files, they are just plain text files. Why the program is using a tool meant for something like this? It's like using fancy recipe book to read a grocery list. Okay? Connecting the dots. Leo and May suspect that this might have to do with a Windows trick called INI file mapping. This feature can redirect programs that are looking for INI files to check the registry instead of the actual file, like a detour sign that sends you to the wrong address. Okay, finding the problem. They check the registry and bingo, someone has set a rule in there that says hi for all requests using the profile API. Go to the registry and look for something called sys. Normally, this kind of rule might only apply to specific files like autorun.inf, but this one is a blanket order affecting everything. So even when a program tries to read a regular text file using these tools, it is sent to the registry instead. So uh, this uh, function, okay, it is used to uh, it's used to uh, read .ini files. So instead of doing that, it is going to the registry. So the problem is they check the registry and bingo, someone has set a rule in there that say, hey, for all requests, so I think this is related to the .ini file for the program that failed to open the .text file. So here you can see that this file set a rule that in there, hey, someone for all requests using the profile API, go to the registry and look for something called sys. Normally, this kind of rule might not apply to specific files like auto.inf, but this is a blanket order affecting everything. So even when a program tries to read a regular text file using these tools, it is sent to the registry instead. Why it is failing? Let's see this. Here is the kicker. A lot of older programs use the profile API to read all kinds of text, not just .ini file. So this is here the trick. Profile API is used not only to read .ini file, but to read text files in older programs. Okay. When they get redirected to the registry, they try to write something there because that's how the API works, but they don't have permission. That's when the access denied error pops up and the program gives up. So what we can do, the solution is simple. They remove that bad rule from the registry. Once it is gone, the program stops talking the editor and can read the text file directly from where they have stored. Problem solved. So, okay, a familiar pattern. Maya points out that this reminds her of a previous case where in-file mapping caused problem. Back then, it was just for a specific file, autorun.inf, but the idea is the same. A misconfiguration tricked programs into looking at the wrong place. So this is the case, and I think now it is cleared. Okay, now we can go to case number 8, the missing folder association. Here is a weird one. A user gets an error message whenever he tries to open any folder. This file does not have a program associated with it for performing this action. That's just the folder association in the registry is broken. Let's use Procmon to compare with a working system. He's trying to open any folder, saying this file does not have a program associated with it. So there's I think a problem is the Windows Explorer. There's a folder association in the registry is broken. Let's use Procmon to compare with a working system. They run Procmon on both systems and try to open a folder. How to approach comparing the trace between two machines? We will need to be methodical. First, we will filter both traces to show only Explorer. Yes, that's what I'm talking about, .xi, .exe event. Then we will look for the exact thread that handle the double click action. Double click action. So I think here we can see, for example, I have Explorer. I think here I have some Explorer things. So, for example, let me filter. We can tell it to operation. For example, let's filter the operation of is Explorer. Let's say that Explorer.exe, and let's add this and apply. So there is no something like that. Let's reset, apply. So where is the Explorer here? I cannot see that. Let me, there is no Explorer here. So there is, okay, but it is in the process name. So let's filter. Okay, it is the process name is explorer.exe, and tell him add and apply. So now we have all of the process, or we have the explorer.exe. We can see here the action, create file mapping, registry open, close file. For example, we can see here this is an action to close a file. You can filter it more, for example, to see opening a file. So we can, for example, also filter it more. We can do like this. We can tell him, we can tell it as operation. For example, here, let's filter it more. We can go to the operation is, let's close. We can tell him close file, for example. Let's do like this. Include, tell him add, then apply. So now we have all of the closing, or what we hear, the action of a close or to close a file. We can tell him to, for example, write a file, delete a file, read a file. So we can now filter it as far as we need. So let's continue. Here is saying that then we look for the trace that handling the double click action. So I think double click action here, I think it is opening the folder. Leo filters the trace and identify relevant thread. Now let's compare the registry operation side by side, looking for differences. So opening a folder will lead to something in the registry. Let's see that they arrange the traces for comparison. Here is something on working machine. Explorer successfully opens a registry key called HKCR folder share open command, but on the broken machine it gets name not found. That's our answer. The registry tells, a key tells Windows what program should handle folder objects. Without it, Windows does not know how to open folders. Okay, that seems to be a logical thing. So we now can export that key from the working machine and import it to the broken one. Exactly. They should restore the folder association. They demonstrate fixing the issue by importing the registry key. That worked. The user can now open folders again. That's a great example of comparing traces between working and non-working systems. Can quickly identify configuration differences. So I think this is a good example also of how we can open or open folders. So this is key HK. I think this is a different HKCR. I don't call, I cannot recall a key like that. Let me open regedit. Is something called HKCR. So we have HK uh, HKC. I don't think there is something called HKR. HKCR, yes, current HKCR key class root maybe. And then we have something called, here is talking about folders. Let me see if there is a key like that. F. So we have FO FO, I do not think so. We have FOLD. Here is the folder, yes. And then we have shell, and then we have open command and command again, but on the broken machine goes name not found. Okay. Okay, so this is the thing to open the folder. So this seems to be a good one. Okay, so seems to be very good. To open a folder, you need to go to the registry that will tell the Windows to open this. So if you try to ask Windows to open a folder, it goes to the registry to see how it can open this folder. It's something like instructions. Okay, so here we can see that this is our the registry key tells Windows what program should handle folder objects to open folders. Without it, Windows does not know how to open folders. So this is one case which seems to be a good one. As for this one, I have already seen this case and it happens in front of my eyes, the temporary registry profiles. This case affected multiple users and organization. Users could occasionally get a user profile service failed error at login, forcing them to use a temporary profile. So when a user try to log in with his account and he have a successful username and password, he logs in, but his profile is empty. So for example, I have my username and I have a certain profile that contains some icons on my desktop, some background setting. When I log in, all of this disappeared and I have a default profile setting, something empty desktop, a standard background. All of this is called temporary profile. There is a problem, okay, uh, something called user profile service failed. What or when I try to solve this one, actually I go to the registry and delete all the profiles, okay, or non-used all the profile Windows profile, and this solved the issue. Let's see how this will be solved here. That's serious. User would lose access to their setting and files. The challenging part was that it happened intermittently. Let's see how Procomon help us. But Procomon wouldn't be running before the user logs in, right? Yes, that's where Procomon boot logging features come in. So we can tell Procomon to, so we can tell it to uh, enable boot logging in Procomon. So how we can do that? But Procomon would be running uh, before the users log in, because we needed to capture the error before logging in, because this is where the error appears. So he's saying that we should log in and enable boot logging. So where is the enable boot logging? In options, we have something called enable boot logging. Okay, so without boot logging, Procomon will start capturing events very early in the boot process, including the user login sequence. They examine a boot log showing the profile loading failure. That's it. Look at this error in the login. The profile failed to load with error 32, which is error sharing violation. Something has the profile registry hive file open, preventing when login from loading it. Okay, again, this error is something has the profile registry hive file open, preventing when login from loading it. What could be holding it open? Let's look at the processes that are running just before the error. Uh, they review the process tree in Procmon. See these multiple lsass.exe processes. That's unusual. Looking at the events just before the sharing violation, they locate the relevant events in the trace. Here we can see SSON which is a part of the Certrix ICA client, opening the user netnt just before Windows login tries to load. But why could a Certrix component be accessing user profile during login? Let's look at the call stack of one of these file operations. They examine the call stack. Found fascinating. The Windows logical prefetcher is responsible for the file access, not ssonsvr.exe directly. The prefetcher is trying to optimize this program startup by reloading files uh, it accessed in the previous run. So there is a race condition where the prefetcher is accessing the profile hive at the same time in login try to loading it. The logical prefetcher was incorrectly associating Windows login access of your register hive with the SS sensor setup, creating this conflict. How do you fix something like that? In this case, the solution was to add a delay in the Certex network profile DLL to ensure SSM4 launches well before login tries to load their profile. They discussed the implement. This was not my case. This was another case. I have a profile that was not loading. Uh, I have a case, but it was different. A user, when he tried to log in with his profile or with his username and password, the profile was not loaded for this user. So I have deleted it. There is a problem with the profile, so I have deleted it from the Windows, but still the problem. So I have to delete it from the registry as well. So this solved the issue. Uh, let's see here. That's impressive. Without Procman boot logging and stack traces, this would have been nearly impossible to diagnose. Indeed, the stack trace feature is incredibly powerful for finding out root causes of complex issues. I think we need to have this case re-explained because I think I am not fully understanding this case. Let's try to copy it and try to uh, make Grok to explain it, and I focus on Grok because his explanation seems to be simple. Explain this case in layman terms and include glossary terminology glossary, and let's see how he will explain that. I think we have. Okay, let's this to be our last case or the case before the last one. Okay, let's see how he will explain this. So imagine you are a part of an organization where people use computers every day. Sometimes when they try to log in, they hit a snag. An error pops up saying user profile service failed. When this happens, instead of seeing their usual desktop with all their files, setting, and all personal touches, like their favorite wallpaper or saved documents, they get stuck with a temporary profile. It's like the computer forgets who they are and hands them a blank slate. That's it. None of their stuff is there, and anything they do while logged in wouldn't stick around for the next time. It is a real hassle. What makes this problem even trickier is that it does not happen all the time. It is intermittent. Some days user log in just fine, other days they get the error. It's like a glitch that only shows up when it feels like it, making it tough to figure out what's causing it. To crack this case, two troubleshooters, Leah and Maya, step into the tool called Process Monitor or Procman for short. Take Procman as a super detailed journal that tracks everything the computer does, which programs are running, what files they are touching, and what setting they are tweaking. It's perfect for spotting what's going wrong, but there is the catch. This error happens during login, okay, before the user even gets to their desktop, and normally Procmon only starts after recording after they have logged in. So how do you catch a problem that happens before Procmon usually kicks in? Okay, There is where boot logging saves the day. Boot logging is a special feature in Procmon that lets it start recording the moment the computer powers on, way before anyone logs in. It's like setting up a security camera to watch everything from the second the computer wakes up. Leo shows Maya how to turn on this feature so Procmon can capture every step of login process. Here is how it plays out. With boot logging enabled, the next time a user logs in and gets the error user profile service failed, Brockman is already on the job, logging every detail. Afterward, Leo and Maya can dig into this log to see exactly what happened during that failed login. Maybe a file could not be found, or a setting was messed up. Whatever it is, the log points them to the problem, like replaying a video to spot where things went wrong. Once they figure out the cause, say a permission issue or a broken file, they fix it. After that, a user can log in without seeing the error and the regular profiles load up just fine with all their files and setting intact, problem solved. In short, this case is about tackling a sneaky login issue that randomly blocks users from their profile by using Procmon boot logging to record everything from startup. Leo and Maya catch the culprit in action and getting things back to normal. It's like being detectives with a high-tech tool to solve a mystery that pops up now and then. But he didn't say what was the issue. The issue that there was a program that was trying to open or to play with the user profile setting. At the same time, the Windows is asking to access this profile to load it. So normally when you put your username and password, the Windows loads the user profile. But at that time, there is another program trying to play with the user profile or opening the user profile, which is, as he has said, something called Citrix, or there is the program, let me go, Citrix ICA client. Okay, this is it. And again, he was not the responsible that, or he is not the one that is opening the or using the user profile files. No, the prefetcher, which is a feature that makes loading of the programs faster, this is the one that's trying to uh, open or lock the user profile. The logical prefetcher was incorrectly associating Windows login access of a user registry hives with the CS sensor. So, what means by that? The prefetcher is trying to make the Citrix ICA agent log faster, okay, related to a certain user profile. Okay, so this is the problem, okay, that this is what did this problem. And to solve it, they, let me see here how he solved them, is to add a delay in the Citrix network provider DLL to ensure this program launches well before Windows try to load there. So we can tell this program to load or to delay its auto start so it can be after the user logs in, not before that. Okay, so this is something impressive. We can see this is the error and how it was solved. I think we can take another case, the Office RMS error. Here's a case about right management service. This is a feature that you can, or a role in Windows that you can set up to control who can access Office documents like Word, Excel, PowerPoint. You can tell, for example, some people to have a certain read permission to a Word file, write permission to a certain file, modification, something like that. So let's see. A user was getting vague error message when opening RMS protected Office documents. So this is a feature that are enabled on documents. You need to enable this feature on documents so you can use it. For this one, we will use debug view, another Sysinternal tools that capture debug output from application. This is another uh, uh, software I didn't use before. It's called debug view that captures debug output from applications. Leo demonstrates configuring RMS debug tracing, registry configuration to enable RMS debug output. So we need to do a couple of registry keys to enable capturing of errors related to the office protected documents. So he have add these two registry keys. Now we will start debug view to capture the debug output. I think this is the debug. Let's close this one. We have something called debug view. Let me see it in sysinternal suite, something called debug. This is the debug view. If we can open it like that. So here we need to capture. So we need to do a registry setting so we can begin capturing. So okay, anyway, so let's close this one. So we need to do these two registry keys so we can begin capturing. Okay, Leo reproduce the error while debug view is running. Let's search the debug trace for any error. Control F in debug view and search for error. Here is error code 12057. That looks significant. Good catch. Now we can search online for the specific error. They search and find a Microsoft KB article explaining that this error relates to an invalid certificate revocation list in the SSL certificate. So this is something related to authenticating the user to the right management system so it can give him access to the protected office files. Now we know the exact cause. The SSL certificate being used has an invalid CRL distribution point. Replacing a certificate with a valid one will fix the issue. That's correct. Debug error. Debug view revealed detailed error information that the application UI wasn't showing. That seems to be a recurring theme with troubleshooting. Absolutely. Application often swallow detailed error information and present a generic message to users. Our tools let us see what is really happening behind the scenes. So this is it. We need to add these two registry keys to enable RMS debug output. So this is only for RMS. So if I need to debug another program, I need to do something. How I can do that? So for example, let me see something like that. So if I'm opening it, let's say capture. So if there is a program or there is a problem, it will capture it. Okay, that seems to be good. If there is an error, you can capture it, or you can click and capture the error and then begin debugging. Okay, so we can here to capture Windows 32, capture global capture kernel, enable verbose kernel output, log boot. So a lot of things actually. Options Windows 32, bid force, clock time. We have a lot of things actually here. What is this one? We have clock time, show milliseconds, history depths. A lot of things we can see here. Computer, we can also connect to another computer. So this seems to be good. And then we can begin working with it. So we can see from here also process crash dump. There is also you can process a crash dump from here. That's good also. So you can analyze crash dumps by this one maybe. So anyway, I think we can stop at that case, the case number 10. In the upcoming video, with God will, we will see the failed force functional level raise. This case involves Active Directory and administrator was unable to raise the force function level from Windows 2000 to Windows 2003. Very, very old operating system, but let's see if this appeared with us, how we can solve it. So we will stop at case 11. Hope this video is informative to you all, and thank you all for viewing. Thank you so much.